Um, Good morning, everyone. Let's have ourselves for our prayer. Father, King of Kings, we thank you so much for today. We thank you so much for our lives. We thank you so much for our parents, for our teachers, and for our friends. We thank you so much for this week, and we pray that as we go into this lesson, you shall help us to understand each and everything that will be taught. And we pray for those that have not yet joined in to join in. And we pray for our networks today that they will be stable, King of Kings. We surrender each and everything to you. Through Christ our Lord, I've prayed and believed. Amen.
Amen. Thank you, Gift. So last week you looked at binomial distribution, and we left off when we had told you to go through the questions. I don't know if you went through the questions. Did you go through the questions? Can I hear from you? Yes, and I made a correction on number 2. I think I've picked the old document. I missed out the word ripe here. So I don't know those who picked the old document, if you corrected it. There was a word here. Okay. So I'm now looking at the probability that an orange is ripe is 0.2. Okay. I think that's why Mrs. Kasamba skipped it last time, because it wasn't clear. But that alone couldn't stop us from doing it. So guys, did you do the questions? Yes, Kathy?
Sure. Okay, number 2. Okay, like there are mangoes in the question, and there are mangoes in the A and B, and the first part has orange instead. So I thought that there was an error and I made them orange.
Yeah. This is also mangoes. Okay. So, yeah, we can make those corrections. I think I hadn't actually seen that. I mean, my focus was on that. So with those corrections, I think the question is now maybe even down here.
The problem number 6 even.
Okay. So those are the 3 corrections I made, but I shared an edited document. I think I'll have to go and I check. I don't remember changing the word, that word of orange. It has to be mangoes. Okay. Yeah, so make sure you have the correct wording so that it's easy to work it out. Okay, yeah, I was asking you if you guys did the work. Can I hear from you?
Yes.
Yes, Kathy.
Yes, I tried.
Kathy's hand is up.
Yes.
Okay.
I did, but I got stuck on number 6.
You got stuck on number 6.
Yes.
Number 6. The rest of the questions were fine. How did you do number 4? Can someone tell us how that person did number 4? Anyone who did number 4?
I did.
Okay, I can
did.
see Mrs. Kasamba is in class. Assumpta, good morning.
Morning, Mr. Mirinda.
I was worried. I thought you had forgotten about the lesson. So
no, I was in the other room. I hadn't joined the breakout. I was there by 20 past 10. Then I realized that there are breakout rooms.
Okay, so I'm asking the girls what they did as far as these questions are concerned. So maybe you can pick it from there.
Okay, Sebo.
So girls,
I saw Kathy's hand up. I don't know, Sibira. Oh.
Yeah.
yes.
Sure, just asking who did number 4.
Yeah, because I think we left off when you had done number 3. Are you saying that in the whole class, I'm seeing these are 31 girls minus the 2 teachers? Are you saying in the whole class, we don't have anyone who tried out? Yes, Kathy.
Sure, I did number 4.
So what did you do? Can you tell us?
I said, okay, for part A, said that n equals 8, then q is. Did I first read the question?
Yes.
In the part A, I said n is 8 and q is 60 out of 100, which is 0.6, and p is 0.4. So p x is equal to 3. It's going to be 8 combination 3 times 0.4 to power 3 times 0.6 to power 8 minus 3, which is 5. And the answer was 0.2787.
Okay, did you define X? What was X representing?
The number of balls.
Yes. Was representing the what?
It's not representing the number of balls being
Which
picked.
balls? Because you have 2 carrots. So which of the 2? You need to be
red ball.
Yes.
Red balls.
So if you let X be a random variable representing the number of red balls, then you went ahead and used that X, and you've told us that for part A, you got X equal to 3.
Yes.
First of all, X is throwing a binomial distribution. You've told us your P is 0.4. What was your N?
8. The N is 8.
N was 8. Okay. So when you use that, so exactly 3 is what? 8 combination 3.
Times 0.4 to power 3 times 0.6 to power 5. 8 minus 3.
And you've said you got which answer?
0.2787.
780. Okay. Is that what other people got? Can we hear from you? Or the rest didn't try?
Yes, that's what I got.
So can you tell us what you got for part B? How did you do it?
Part B was at least one will be red. So that is a probability of x greater than or equal to 1, which is the same as 1 minus the probability of x less than 1.
Do you have babies?
Yes.
So what do you get here?
It's a probability of 1 minus the probability of x is equals to 0.
Which is?
1 minus 8 combination 0, which is 1. Okay. 4 out of 10 to the power 0. And then 0.6 to the power 8.
And what are you getting here?
1 minus 0.0168.
And your final answer?
0.9832.
9832. Okay, guys. Anyone who got a different answer from what your friend has just told you? Okay. Silence means that you are following. Can I get someone to tell us how she did part C? Anyone to tell us how part C was done? Mrs. Kasam, do you have students in class today?
I don't know. I'm hearing a lot of silence. Maybe they didn't look at the work.
You can't have a class of, these are 38. And actually the attendance is not that good. I don't know if some have moved to international schools, which I doubt, because other days we have bigger numbers.
Like, what is the maximum so far you've been having?
I think we've had more than 60, if I'm not mistaken, like around 70.
The time when before they started paying.
Yes.
Yeah. After payment, all other groups the numbers have reduced. Some parents don't have the money.
Okay. Can I hear from people what they did? I've never heard from Rhoda Nabu Kenya. She's always in class quiet. Rhoda, did you do part C? Rhoda? Is Rhoda in class?
Yes, teacher.
Rhoda, good morning.
Good morning. I'm not sure if you can hear me.
Yes, I'm hearing.
Pardon?
You're always quiet. Can we hear from you? What did you do on part C?
Of which number? I've just come in.
You didn't attend last week?
I did.
You did. We are looking at number 4. Are you seeing what is on the screen?
Yes.
Yeah, we are doing number 4, part C. Do you have an idea?
I've seen it. And how to do it.
Yes.
Teacher, any idea on how to do that part?
Yeah, did you do it anyway? Because last week we told you to do this work.
I didn't do it.
Why?
Yes. I think I forgot that we had this assignment.
Girls, how you perform in mathematics is as a result of the effort you put in. So when we tell you to do work and you just keep the work and you expect the teachers to come and go through it, it's not really helping yourself. Yes, Hadija.
Yes, teacher, I did part C.
Okay, how did you interpret it?
They said that more than 4 will be yellow, so our P would change to 0.6.
Okay.
Then the Q to 0.4 and the N remains the same, 8.
Okay, I hope everyone is seeing that, because part A and part B, they were talking about red, but in C, they have now interchanged. So you have to bear that in mind, that now your success, the probability of success is going to change. So we can use another letter. We can say let Y be a random variable. Okay. Number of yellow balls. Okay. So in this case, your Y is going to be the variable in question. Okay. So you can say Y is following a binomial. Your P now is going to be 0.6. The N doesn't change. Okay. It is the P which changes. So the question was clear. They wanted you to find that Y.
Excuse me, Mr. Nirinda.
Yes, please.
Maybe we keep the notation of to NP. You're writing PN.
Sorry?
We keep the notation to NP. We start with 8 and then 0.6. They might get confused along the way.
Oh, okay. NP. Okay. So this is 8 is 0.4. Okay.
0.4.
Then this is 0. This is 8.
No, 8. Good.
Then 0.6. Okay. Thank you. So more than 4. Adija?
Yes. The probability of y greater than 4 is equals to the probability of y is equals to 5 plus the probability of y is equals to 6 plus the probability of y is equals to 7 plus the probability of y is equals to 8.
Okay. I hope your friends are seeing that. This is the wronger route. Okay. So when you work it out, you can tell us the final answer since there are many probabilities in there.
My final answer is 0.5941.
5941. I don't know what your friends have.
Have the same.
Yes, you got the
same.
same. Okay. Mrs. Kasamba, do you want to come in there?
Oh, yes, Mr. Nirina, could we bring in also the use of the tables here at this moment?
Sure.
Is it advisable?
Yeah.
I don't know if they have the tables, but I don't have a copy.
Yeah, they will tell us. Do we
Girls,
have
do you have the logbooks with you? Or you can figure out where they are and we pick them very fast. Hello?
Can we know if anyone has that
pick
logbook? Or if you can pick the books quickly. Okay, maybe do we have anyone in class with a book?
Yes.
Okay, can you turn those pages and you tell us which page is having the cumulative binomial distribution?
Okay, maybe we need to guide them.
Yes.
Can we go to page 43? 43, what does the title say on page 43 and 44 of your logbook?
Binomial probabilities distribution, BNX individual terms, PR.
There is that word individual terms.
Yes.
Now, where we have the probability, I don't have a screen. Mr. Nirinda, can you allow me to have a screen? Okay, I'm just going to use, I like using Microsoft, I don't know why. So individual probabilities, these ones are referring to the exact probability. So where you have something like the probability of, you want to find the probability of the variable being equal to a particular A. I'm generalizing. Here we can just straight away go to the log, but there is some caution to add. This one pays, when you look at those tables, what does the first column give you? The first column, what is it giving you? The very first column of the values. What is written on top? Oh, N, good. So you see, we talked about the parameters or the quantities that describe a binomial. There must be N. Then what do you notice? Sorry, small n. What do you notice about the second column? The second column is a little bit wider but it has something there. What have they written on top? Or what do you see on page
R.
43? R, good. Uh-huh.
We lost Mrs. Kasamba. Else? Yeah, it seems we've lost Mrs. Kasamba. But she was trying to help us understand how to use those tables. As we wait for her to return,
I don't know what happened to my network.
okay, since you're back, you can continue.
And it just happens. I don't know why. Okay, let me continue. Okay, they were telling me what else do you see in the table? There is R.
Can share your screen, Mrs. Kasamba.
Oh, I had taken it off. Okay, share screen. Girls, what else are we seeing in the what else are we seeing in the table? Let me try to imitate it a bit, but it's not easy. The first column is giving us R, small r, and then we have, sorry, N, then we have R, but it's not how it is being written, but what else do we have? I think something like that. What else do we have on top?
X.
There is some, we have X. Is it X? Okay, what values do you see from there?
0.01.
Okay, you have 0.01. Is it
Then-
0.01?
Yes.
Yes.
Okay, then
0.05.
Then you have 0.05.
Yes.
Is it like that?
Yeah.
Then
0.10.
0.10. Then
0.15.
15. Then
0.20.
0.20. Then
0.25.
good. Then
0.30.
then
0.35.
then
0.40.
then
0.45.
then
Finally 0.50.
50. Okay, this one is not exactly the same. Now, you notice that N, those are the number of independent trials, okay? Which comes in under 8 combination R. Remember combination R, so you'll have the R there. And now these values are giving us the probabilities that have the probabilities of success. And you notice that they are from 0.01 to 0.05. And they are all multiples of what? They are multiples of what? What do you notice? They are multiples of 5. Good. So this table has an advantage over the formula, and also an advantage has some, the formula has some advantages over the table. Now, since we are looking at these probabilities, I will explain more. Now, let's go to the number we have looked at. Our probability of success was 0.4, not so?
Yes.
Then N was?
8.
8. So you're going to look under 8. You go up to where 8 is. You go up to where 8 is. Let's say it's there. And what is our R?
3.
3, yes. So you go down up to 3, yeah? Now you're going to look at A as 8, R is 3, then where P is 0.4, you'll find that there will be a value coinciding there. Can you read for me the value which is appearing here? My cursor, where is my cursor?
2787.
At the intersection, 2 what?
2787.
2787. 7. Now, because the space is not enough, this is not just 2787, it is 0.278. So they remove this 0 point appears only at the beginning. So our probability of success being 0.40 and n is 8. What value did you get? Was it Hadija who gave us the first answer?
No, it was Kathy, but that was the answer, 0.27.
Do you see that you go there very fast from the tables?
Yes.
So it's allowed to just pick the value from the table and you quote it, you write it there without going through the formula. So this only occurs, we use this table when it is for individual probabilities. Can we go to part C of that question, where the probability of success changed to
0.6.
0.6 and was, no, okay, no. Let's go to the next part, sorry. The next part was what? More than, what was it?
More than 4 will be yellow.
More than what?
At least one will be red.
Oh, at least one, eh? Yes. Now, at least one, you would say, what did you say? 1 minus probability of x less than 1, eh? So you'd have done, okay, at least one, you'd have done this, at least one, that's what you did, eh? You got that, and then you said it's equal to 1 minus the probability of what? X being equal to 0, not so?
Yes.
So you'd have now, this is an exact value, eh? You'd have now come to the table, n is 8, but r is what?
0.
0. And the probability of success is still 0.4. So can you read for me the value there?
0.168.
0, let me just write it here. 0 point what? 1?
0.0168.
68, not so? There is a 0, eh?
Yes.
0.168. Is that what you got after calculation?
Yes.
Good. So you see how fast it takes you there? Hello?
Yes.
Yes.
Okay. Now, that is when we have individual probabilities. We have now another table on page 45. Can you go to page 45? This was when we are looking for individual probabilities. Individual probabilities. Now, what if you need a sum of many of them? Probabilities. Individual probabilities. How do they? Now, there is a moment where we need to sum up. What does the title of that table read? How does it read? On page 45.
Binomial probability distribution.
Good. Cumulative what? Cumulative binomial what? Binomial probabilities.
Probability.
And there is some notation being put there. Not so?
Yes.
Yes.
Now, this table strictly works for the following, where you have, now like this one, I'm going to generalize it. Strictly when it is greater or equal to. And in case the question is not in this format, you have to bring out, as we shall see. For example, our previous example, part B, required us to find what? Less greater or equal to 1, not so?
Yes.
Now, instead of us going through the other steps, at 1 minus this, we could now read this value direct from this logbook. Now we are going to do the same. Can you now go to where you read for me? N is what?
8.
8, and R is what?
1.
1. And the probability of success is?
0.4.
So can you now read for me the value that is there, which is written there?
0.9832.
932, not so? What
Yes.
did we get here? I left this one hanging so that we can go back. Isn't it the same answer?
Yes.
So we are saying we could use the formula to find this probability. We can use individual probabilities to find this answer, but we have now a direct route, provided it is in the format at least. We straight go to the table on page 45. This one is now summing up. It's summing up probabilities from the values which are greater or equal to R. Are you seeing how things are interesting? You directly write it. Okay, let me go back. Part B, do you all appreciate part B? We understood the first formula bit, not so?
Yes.
Now I'm saying we can also use the logbook to find the value of that probability, right? Am I with you? One way was to look at it as that, whereby we shall now use the individual probabilities tables, because now here it's appearing as exactly 0 times. So you'd go and then you'd answer it using that. But because our probability here is in the format x is greater or equal to 1, the mathematicians computed all probabilities in this format. You can now use that, another table, to take you there directly to the answer without going through those other steps. Still, they depend on the parameters N, R, and P. So N is 8. In this case, R is 1, and the probability of success is 0.40. So because it's in this format, you go to the table on page 45. And then you start reading. You notice that R is 1, N is 8, R is 1, and P 0.4. The point of intersection of those three will give us that value directly.
Thank you, teacher.
I don't know if you have understood it. If you don't have the logbook, you'll check after. So
I have a logbook.
Oh, you have a logbook, eh?
Yes.
Now, let's go to the next number. What was the next part?
More than 4 will be yellow.
More than what?
4 will be yellow.
More than 4 will be yellow. Now we are saying you could use the formula, not so? And then notice that the probability of success has changed now. It's no longer red. Not so? And you remember, Mr. Nirinda explained, N is still 8. R is what? R is 4. And P is now 0.6. Are we in position to using the logbook?
No.
No. It is both yes and no. Yes, we can. Now, we can do so when we change the probability of success. Now, if more than 4 will be yellow, can we relate it with our being red? How many will be red?
Less than 4.
Than 4.
Pardon? We are saying
Less or equal
Less
to
than
4.
4.
let me come back, sorry. We are saying they gave us more than 4, More than 4 will be yellow, not so? And that is using the formula. What I'm saying, one can reason out, if you wanted to use the logbook, you can say, this is the same as, what are you telling me? If you used X, more than 4 will be yellow. How many will be red?
Less or equal to 4.
Less or equal to 4.
Less or equal to 4. Is that so? I'm following you.
Yes.
Less or equal to 4. Are we in position to finding this from the logbook? Yes.
Yes.
Are using individual probabilities, not so? 1 minus da 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 da, not so? But we can now,
Yes.
we can relate this to, can this be the same as 1 minus what? Probability of what? What will it be? What will it be?
Oh.
Pardon?
X less than 4.
Greater than.
Hello?
X
X greater
less
than.
than 4.
Less than 4,
Yes.
Greater than.
Okay, now I'm going to ask you, is there a way, maybe, can I now write X being less than 4 in this format? How else can it be? X less than 4, can you figure it out? Less than 4, do you think it can be put into the format of greater or equal to? This one is now very mathematical. Can you say to probability of X greater or equal to something?
Is it?
I'm waiting.
Is it?
Is it what?
That? Is it less
what?
than?
Will it be less than?
Shouldn't it be
Is
1
it
minus
less than 4?
X greater than 4?
You reason out. You tell me. You're telling me what? It will be what? 1 minus what?
Ability of X greater than 4.
Oh, greater than 4? No. No, I'm interested in this one. I want us to see how we can use the table. The cumulative table can only cater for X greater or equal to. Is there a way? Okay, now let me show you. Let me show you what I want. Control C, let me put it here. Control V. If I had, sorry, undo. Sorry, Control C. I hope time isn't. Let me put it outside here. Control V. Okay, if I was only dealing with this, could it be the same as 1 minus the probability of X being greater or equal to 4?
No.
Is that so?
No.
It's not true, eh? Okay, values of X less than 4, we have 3, 2, not so?
Yes.
Then those which are greater or equal to 4, we shall start from 4, 5, 6. When you add the 2, let me take this one. If we added the 2, let me see, Control C, and I bring it here, Control V. Because if I added the 2, will this one be equal to 1? Is that so?
Yes, teacher.
If I had, let me just have another set. Let me copy this one. If I had, Control C, Control V, if I had X is less or equal to 5, will it be this when I add 2, those which are greater or equal to 5, sorry, to 5, will it give me 1 as well?
Yes.
Do you understand what I'm doing? Like, let me first list, let's list the values which are less than 4 are what? We shall see 3, 2, 1, and 0, not so?
Yes.
Then values which are greater or equal to 4, we shall start from 4, 5, 6, 7, up to 8, not so? Now, when you add the probabilities of these values plus all these will now give us the total probability, which is 1, not so? Now, what am I trying to do here? I want us to learn how to relate that if it is less than, it will be the same as what? Now, if I took this the other side, now I want to make this one the subject. I'll take this side and then take it that side and then to be minus, not so? So is this statement correct? But
Yes.
probability of X being equal to that is true, not so? Now I'm going to read this only from the logbook. What is the probability of X being greater or equal to 4 from our logbook? Remember, we are now dealing with X where N is 8, R is 4, no, yeah, R is 4, and P is what? 0.4. Because now it has changed from Y to X. I hope we are doing the right thing. Can you read for me? No, you girls, you did something wrong here. Being greater, was in this one Y? No. Okay, let's first continue. Give me the value when N is 8, R is 4, and P 0.4. We shall find it out.
I think the problem is on that part of Y minus probability of X. They put less than 5. I think Nanyunja tried to correct you, but you seem not to have.
I didn't hear. What did she say?
Intentionally, it's supposed to be X greater than 4, I think.
It's greater than 4, eh?
Yeah.
This one, eh?
Next, the one which has 1 minus.
This one, eh?
Yeah.
Oh, it is greater, eh?
Mm.
Sorry, I didn't pay attention to her correction. It's greater than, eh?
Yeah.
Oh, then we take the different route, eh?
Mm.
Oh, okay. I was explaining the one of less than. Maybe we shall come back. Let me first now explain when it is greater than. Ooh.
Okay.
Okay. Sorry, thank you, Mr. I hadn't heard what her comment was. Now, girls, we want to learn how to use the logbook if we had maybe such notations. You realize that one has an advantage over the other, as we are already observing. When it's not exact, you need now to manipulate that inequality into greater or equal to. Now, if we have X is greater than 4, how are we going to introduce the greater or equal to without affecting this inequality? I think that is okay. X is greater than 4. What will it be equal to if I want this one now to be greater or equal to, but without affecting? Now let's first list values which are greater than 4. We have, let me list them
5,
outside. We have 5, then
6, 7, 8.
10, 7, and 8.
Yes.
Now, how do you write them better? With a greater or equal to sign.
X is greater or equal to 5.
Good. I think now you see that. What have we done? What have we done to the 4?
We added 1.
Good. So when it is greater than, in order to create the cumulative binomial probability, we simply now add 1. So we can now read this value from the logbook. What is the probability of x being greater or equal to 5 from the logbook when n is that? And p is that. Now remember, R has changed. Our R has changed to 5, p is 0.4, and 8 is, n is 8. From the logbook, what do we get? Those of you who have the logbook? Hello?
P is 0.4.
R is 5, R is 5 now,
We get 0.1737. 1737.
0.1. Which tables are you reading? Cumulative.
Yes.
I didn't hear the next digits. 0.1 what?
1737.
37. Now we go back. This is what we want. 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 So it will be, at the moment it looks long, but when you master the steps, you do it in a short way possible. What answer do you get? 1 minus 0.1734. Sorry, 37. What do you get?
0.8263.
8263. 63. Is this the answer we got in part C? Hello?
Adija gave us the answer. Can she tell us? Adija?
Is this the answer we got?
No, I didn't get that answer.
What answer did we get? I know where the problem is.
I got 0.5941.
0.5941. 941. Now this is where the problem is. Now I asked more than 4. Okay. More than 4, but I think that more than 4 will be yellow, not so?
Yes.
We can pick this. What did you say? And probability of success is 6. So using the formula, can you remind me what you did? We did 8 combination what? 8 combination. Okay, sorry. I know we are going to rectify it, and that's what I wanted so that we can understand. 8 combination what? 8 combination 4, not so?
No.
Yes.
No. It was more than,
Yes.
So, okay, you did what? You did what? 1. Sorry. Remind me. I don't have more than 4. That is?
It would be 1 minus the probability of x less than or equal to.
Y being less than?
Equal to 4.
Y less or equal to?
4.
Y less or equal to 4. Okay. Yeah, less or equal to 4. Then you did 1 minus, remind me.
Teacher, since it was a halfway journey, I went the other way. I didn't do the 1 minus.
Hey, you did what? You did the 1.
Probability of x is equals to 5 plus the probability of x is equals to 6 plus the probability of x is equals to 7 plus the probability of x is equal to 8.
Okay. you did probability of y is equal to 5 plus probability of y being equal to 6 plus probability of capital Y being equal to 7 plus the probability of Y being equal to 8. Not so?
Yes.
Let me be consistent here. Now I want to come into the formula. I just want to go to the point. Now, what did you get here in terms of the formula? You told me, please hold on a bit. So you told me that it will be now 8 combination what? The first one,
5.
8 combination 5.
Yes.
Okay. Oh, 8 combination 5. 8 combination 5. I'm just going to write combination 5. Then you multiplied by
0.6 to the power 5.
0.6 to the power 5. Then times
0.4 to the power 3.
Sorry, and then 0.4 power 3. 0.4 power 3. This one is enough to demonstrate. Now, girls, we notice here, because we have y is equal to 5, that is there are 5 red, yellow, oranges. So that means it is 0.6 power 5, 0.4 power 3. Now, if I wanted to use the probability of success, we are going to interchange these ones. Do you notice this? If I brought this here, I don't know why. Are you seeing that? Girls, are you seeing what I'm trying to do?
Yes.
When the 5 are yellow, it means the 3 are red. Are you interpreting that? So, because our logbook does not go up to 0.6, now we are going to go to the 0.4 and we make it the probability of success. But as we use it as probability of success, R is going to be 3. Are you now seeing it? So we are going to read from n is equal to 8, R is 3 of 0.4. Let me write it here. That the probability, Control C, Control V, the probability of this will now be equal to the probability of the red ones being equal to 3. Are you interpreting that? Are you understanding what I'm trying to show you?
Yes. Yeah.
That if we wanted to use now the logbook, the logbook stops at 0.5, not so as you can see. But in the event that our probability is like 1 minus 0.6 gives us 0.4, so we change the probability of success. We wrote it very correctly, but now I want to use the probability of success as 0.4. From the logbook, because the logbook can read only 0.4. It means that now R would also change to 3. This power that we are using here is what we now change. Okay, girls, are you seeing this, what I'm trying to do for you here and do? Are you understanding what I'm saying here? That I can now change this to 8, 8, combination 3. Now, this one becomes 0.4 power 3. Let me copy the whole of this. Control C, Control V. So this one will come here. 0.43. Sorry, power 3. This becomes 3. And this one will become power 5. Have we changed anything? Nanyunja. Okay, can you give me the value which you're reading from the logbook? Now we are going to individual tables. What is that value from the individual tables? 8 combination 3, 0.4 power 3. What answer do you get?
0.2787.
That is the first one, 2787. Okay, give me the next one. What will be the next one? Now, probability of y being equal to... What will be the probability of y being equal to 6 if you are to read it from the logbook?
0.2090.
What will it be equal to? It's going to be equal to the probability of what? X being equal to what?
2.
2, good. So this will now be the same as? You read now direct.
0.2090.
2090.
2090.
2090. Is this what you got?
Yes.
Good.
Yes.
Then probability of y being equal to 7. What will it be equal to? I think now we're understanding.
Probability X equals
0.0896.
Pardon?
The
It will be the
probability
same as?
1. 0.0896.
0.0896.
6.
What have I written? The time is against us. But this usually happens 0.0908.
96.
96. Okay. So have you seen the brain twisting? And the
Yes.
brain twists only now in this. When you write it rightly here, you just, I'm going now to use this one of 0.4. As long as these are multiples, the probability of successes are multiples of what? Of 5. But in the event that even 0.7 can also be read from here, when you see that your probability of success is 0.7, you interchange and you find the power to 0.3 will give you now the new R. Now this is when using individual probabilities. Now I wanted us to now, do you notice that when y is greater than 4, did you interpret it correctly here? Did you interpret it here correctly? Here. Is it the same as the red ones being less or equal to 4? Because here you are still in relation to the yellow ones. We can now use this one here. You've noticed, now I'm going to use this one. We've noticed that instead of having this, having probability, Control C, Control V, instead of having this, would say y being equal to 8 would be the same as probability of what? Probability in terms of x, x being equal to, the first one was what? X is equal to 3, Then plus probability of x being equal to 2, then plus probability of x being equal to 1, then plus probability of x being equal to 0, not so?
Yes.
Now, how can you summarize this in terms of x from here to here, in terms of x? Are you understanding now my challenge? Okay, sorry, this was 1 minus. Yeah. Okay, no, this was not important here. We are looking at another way of how we can use the tables. We are saying that the whole of this is now this. How can you say an inequality from x being equal to 3 to x being equal to 0? What will it be?
Probability of
Less or
X is less than 4.
Less or equal to?
3.
We have 2 ways. Less or equal to 3, not so?
Yes.
Or less than?
4.
4. Are you seeing that now?
Yes, teacher.
You see our interpretation was wrong. We said greater than 4.
Oh.
So the probability of y being less than 4 was supposed to be the probability of x being less or equal to 3 or less than 4. Or probability of x being less than 4. And thereafter, we can now interpret less than 4. Is this what we are interpreting? Now, because it's less than 4, now this will be, we can now take this to greater or equal to, not so? And this will be now a different value. Can you read for me the probability of x being greater than 4 when n is 8, r is 4, and p 0.4? What value would you have here? Hello? Miss Anirinda, are we still together?
322.
Pardon?
0.2322.
22. Are you using the cumulative one?
Oh no.
You didn't use the cumulative one. Go to the cumulative one because now it is that. What is the cumulative one? Because it's the one which gives us x is greater or equal to r. R is 4, n is 0.4, n is 8. Which value is there?
0.4059.
Come again?
0.4059.
0.4059. When you subtract, what do you get?
0.5941.
0.5941. Is it the same answer?
Yes.
Good. What was the problem? When you interpreted the y, you left it as y. Yet now y is, they were yellow, yet x is talking about red. And the table could only help you to read when the probabilities are they were red, because it can only give you 0.4. So here you can see how the brain has to switch. I say that each method or each approach has an advantage over the other. For the individual ones and everything is direct, you get there very fast. But in the event that your brain has to switch from one to the other, there caution has to be taken. But the person who would have used the formula would have gotten there very, very fast. The formula is the most reliable approach because it caters for any type of probability. But the student who has mastered the tables also goes there very fast. You see, oh, you've seen that this is this, you just quote from the table and you add up, or you quote it directly from the table and you subtract. You see, one has an advantage over the other. I don't know if I'm understood here.
Yes, teacher.
Yeah, and choice depends on you. and it needs practice. I say, oh, you've seen how the brain has to play around here with the answers. So in the event that the variable changes, when the variable changes, because here they were talking about them being yellow, and I want to use them being red, I would have done this, and then find out, I would do this and read the individual probabilities, or if I wanted to use the cumulative ones, I would use this. There are three main ways. One, by the formula. When we come to the table, you can use either the individual probabilities or the cumulative probabilities. That is what we have added on today because of time. Mr. Nirinda, are you still there?
Yes, I'm there. I think I'm seeing Mr. Nika in. He's there to tell us that our time is up. We've shot beyond our time by 8 minutes, but it was worth it. I believe we'll pick it from there next week, but in case there are questions that the girls are having, maybe they could try to ask on the Google Classroom.
Yes, sir. So I think this was important to bring it in here as well.
Sure.
For some, but it needs practice.
Yeah, sure. Yeah, but they need to note that the tables work best when your P is in a multiple of 0.05.
Yeah.
Yeah, if it's a different P, then the tables can't work. So
we use the formula.
Yeah, someone who practices using the formula is on a safer side, because
on a safer side, yes,
can take on any P value.
But the one who has mastered the tables can also get there in a twinkle of an eye.
Yeah, sure. If P is catered for.
In that, yes.
Yes. Okay. Thank you, Asumpta. And thank you, girls. I guess we'll pick it from there next week. Hopefully next week we can.
Maybe, yes? Mr. Nirinda,
yes,
maybe I'll send you some numbers for them to try out using both the formula and the tables to practice by themselves.
Okay, no problem. I will share them on the Google Classroom.
Okay.
Okay, thank you. So goodbye for now. Enjoy your weekend, much as it's a Tuesday, because we'll meet next week.